Good morning, friends. In today's topic, we are covering the searching as a topic in the Python programming subject, which is the topic of unit number 5 of the subject Python programming KNC 402. Okay, the searching. If we talk about searching, you simply know searching is what? Searching of a particular element in the given list, or searching for the particular name in the given list of names is, you can say, is known as the searching. Basically, there are two types of searching which we generally study. One is known as the linear search, and second is known as the binary search. Coming to the next, we will first discuss here what is a linear search. Okay, how this method searches for a particular item called the target item. That we are searching an item which is called a target item within a list of arbitrarily arranged item. That is, if we are given a list, let's say the name of the list is, let's say, list L Y S, okay, LYS and T. Okay, this is the name of the list, and let the element in the list are, let's say you are having the elements, let's say 4, 7, 3, 9, and let's say 2. Okay, what they are saying that we are searching for a particular item. We are searching for a particular item which is known as the target item. That is, the item which we are searching is known as the target item from the list of the arranged item. That is, the items arranged here. In this, we are searching the item. In such a list, the only way to search for target item is to begin with the item at the first position and compare it to the target. That start from the first position and compare it to the target. That is, for example, if we want, let's say, 6, then the only way is the linear. That is, we are starting from the first index number value and moving towards right till the last and comparing this item, that is the item which we are searching, first with 4, then with 7, then with 3, and whenever the match is completed, that is, the item, we find the item at a particular location, then what we do, we print the location of that item where that item is present. Okay, now see, if the method arrives otherwise the methods moves on the next position and compares items again. Here in such a list, the only way to search for target item is to begin with the item at the first position, compare it with the target. If the items are equal, it is matching is completed, the method returns true. Otherwise, if the item does not match, for example, if we are searching 6 which is not available in the list, what it will do, the method moves on to the next position and compares items again and again. Okay, if the method arrives at the last position and it still cannot find the target, that is, we have moved to the end of the list and the item is not found, it returns false. That is, the item is not present in the given list. This kind of search is called a sequential search or a linear search. That is, if we are moving one by one, comparing the target element which we are searching one by one with each element, first with 4, then 7, that is, we are moving linearly in order, that is known as the linear search. Okay, or it is also known as the sequential search, a sequential search. A more useful linear search function would return the target of a target, will return the index of a target if it's found, otherwise it returns -1. That is, if the element is present, for example, if you are searching 9, then it prints its index number, that is, it is present at index number 1, 2, 3 and 4, that it is present at the index number 4, and that index number is returned in the program. Okay, otherwise it returns -1. Coming to the next slide, where we will see the program. Okay. Now see, here it is written the program of a linear search. How it is working, just see. Okay, just see here, we have, let's say we have taken a list let's say we have taken a list with the elements 12, 14, 6, 2 and 9. That is, there are 5 elements and which are arranged in random order 12, 14, 6, 2 and 9, and it is stored in the variable list. Okay, now we have defined the function you see with the name linear search. We have defined the function linear search in which target, you can say target is the position of the item if the item is found in the list. That is, if the item is present in the list, then it prints its position from the list of elements available here. Okay, now see, in the linear search we are basically passing the list. Okay, and its the target is basically the output which we are getting. Okay, here you see initially we have set the position as 0. Okay, we have set the position as 0. It is basically printing the index number, not the location number. It's just printing the index number. Okay, we have initially taken the value of position as 0. Then the value we are showing that, see that if position is less than length of the list, here the length of the list is 5 and position is 0. The position is 0 and the length of list is 5. If the position is less than the length of the list, then it's check. Target is basically the value which we are given, which we are searching. For example, here if we are searching the element, let's say 14 in the given list. For example, if we are searching the element 14 in the given list, then check if target double equals, that is we are using the comparison operator, equal to, if target is equal to list of the position, that is the element at the element present at that position or that index number, if it is matched, then it returns the position, that is the output it returns is the position. Otherwise, if it is not matched, it increase the position value by 1. It increase the position value by 1. Again control moves from here to the while loop, checks the condition if position is less than the length of list, condition is true. Then again it checks if the target value is matching the list position value. If both are matching, again then it returns the position. Otherwise, again increasing the position, and this loop continues till if the element till the last index element, last position element, if the element is not present. When the position values get more than the length of the list, then it comes out of the loop and prints return -1. That is, the element is not present in the given list. Okay, after that you see here I have passed the list and the element to be searched. Okay, and the result which will return is stored in the variable. You see here I have taken the variable with the name a, and we have print here the value of a. Okay, you will see that when you have done this, you see that the output it is print is 1, that is 14 is present at index number 1c. You see the 14 is present here and the index number is 0 of 12, index number 1 is of 14, that is it is present at the index number 1, and that is the output. In this way we are working on the linear search. Okay, I think you have got the concept. Now we are calculating the best case and worst case performance of linear search. Okay, we are calculating the best case and worst case performance of the linear search. Okay, the linear search algorithm does less work to find the target at the beginning of a list. That is, if the element is present at the beginning of the list, then the linear search will be doing the minimum work. Then at the end of the list, if the element is present at the last, then the search will continue till last and it is doing the complete work. That is, if there are 1000 element and the element is present at the last, then it will perform the whole search. That is, the maximum time will be applied while searching the element present at the last, or in the case if the element is not present in the given list. Okay, because from starting from the index number 1, it is continuing till it moves to the last index value where the element may be present or may not be present. Okay, for such algorithms one can determine the best case performance. Here thus according to it we can calculate the best case performance of the algorithm or the worst case performance of the algorithm or the average performance. Here basically we are mainly worried about the worst case performance than about the best case and average case. Okay, here basically it is written not basically the 3 cases, we are considering basically 2 cases. Third case we are not considering the average case. In the worst case, the target item is at the end of the list or not in the list. For example, if we are searching the element, it may be available in the end of the list or it may not be present at all in the list. Then the algorithm must visit every item and perform an iteration. That is, n time it is working till the last. It is, you say, it is comparing with all the n elements. Okay, from the list of size n. Thus, the worst case complexity of the linear search moves to the order of n. That is, and the total number of elements present in the array, that much complexity it moves, which is the order of n, that is the linear order. Okay, in the best case we can say the element present is at the first index value, that is it matched with the first index value. Best case means that is the best situation. When the element is present as first index number, that is the best case, and when it finds that the element is present at the first index number, then the time it works is the constant time for matching that. Hence, that constant time is represented by big O of 1, that is order of 1. That is constant time it gets. Now, coming to in this way, we can understand how the linear search is working. The binary search. Okay, binary search. First of all, understand that binary search running time is lesser compared to linear search, but the main condition for binary search is that the element should be arranged in ascending order. That is, the element should be sorted in ascending. A linear search is necessary for data that are not arranged. You see that if the elements are not arranged, then we can apply linear search in a particular order. When searching sorted data, you can use the binary search. That is, if the elements are arranged, that is, if you have been given the list of elements which are already sorted, then compared to linear search, we can apply binary search because it takes less time as compared to linear search. Okay, now to understand how binary search works, think about what happens when you look up a person's phone number in a phone book. Okay, when you see a person number in a phone book, how will you search? That data in a phone book are already sorted, as we know that. So you don't do a linear search. Instead, you estimate the name's alphabetical position in the book. That is, we see by default that the name will be present something in middle or something after the middle or before the middle. So how much pages we can directly move. Okay, and open the book as close to that position as possible. That is, you can move as close as possible. After you open the book, you determine if the target name lies alphabetically on an earlier page or later page. Okay, and flip back or forward through the pages as necessary. You repeat this process until you find the name or conclude that it's not in the book. Okay, similarly, binary search works. How binary search works? To begin, let's assume that the items in the list are sorted in ascending order. For the working of binary search, one thing you should remember, that the items which we are considering should always be present in ascending order as they are in the phone book. The search algorithm goes directly to the middle position in the list. That is, we start from the middle position in the list and compares the item at that position to a target, and then compares the item at that position to a target. That is, first we compare the element with the middle position. If it matches with the middle position, if it matches with the middle position, then we say we print the position of the element where it is present. Otherwise, we check whether the element is smaller than the middle position or greater than the middle position. If there is a match, the algorithm returns the position. Okay, otherwise, if the target is less than the current item, then the algorithm searches the portion of the list before the middle position. That is, it moves backward in the left portion of the list and searches whether the item is present at that position or not. If the target is greater than the current item, then the algorithm searches the portion of the list after the middle position. The search process stops when the target is found or the current beginning position is greater than the current ending position. Okay. Now see about working. Just see here. Okay. The binary search for the target item. Let's say they are, for example, let's say this is the list of 10 items, of 9 items which is available, and we have to search for the item 10, whether it is present in this or not. Then first we calculate the middle of this middle of this array. We see that, and the middle of this array is 5. Then we compare 10 with the 5. Okay, when we compare, okay, when we compare it with 5, we find that 10 does not match with 5. As the elements in the list are already sorted order and 10 is not available at the middle position, then we check whether the 10 is greater than 5 or whether the 10 is smaller than 5. Here we found that 10 is greater than 5. As the 10 is greater than 5, okay, as 10 is greater than 5, then what we will do, we will move in the right portion of the list. That is, we will compare in 6, 7, 8 and 9 whether the element is presented in the number 6, 7, 8 or 9 or not. Okay, here we are doing the working. Okay, here we will see that for searching 10, if we see that again we will calculate the middle of this, and the middle of this is 7, and 10 does not match with 7. We see that a 10 again does not match with the 7. It means that, what does it mean? That the element is either greater than 7 or smaller than 7. We see that 10 is greater than 7, hence we move to the next remaining portion of the array, and here we find that the middle portion is 8 and the element does not match with 8. Again we find its right portion and 9, and we match with 9, and then we find that 10 does not match with 9, hence we say that the element 10 is not present in the array. But if we are searching the other element which is present in the array, then it can be printed here. Okay, in this way by search works. That is, it always finds the middle value, compare with the middle value. If the element matches with the middle value, then it prints the index number. If it does not matches, then it checks whether the element is greater than the middle value or smaller than the middle value. If it is greater than the middle value, then it searches in the right portion. If it is smaller than the middle value, then it searches in the smaller portion. If it is greater, it searches in the larger portion than the middle value, and if it is smaller, then it searches in the smaller portion of the middle value. Okay, elements which are smaller than the middle value searches there. Okay, now see what they have written in the theory. The by search for the target item 10 requires 4 comparisons. If you are searching, okay, the first comparison at this, second at this, third at this, and fourth at this. Whereas a linear search would have required 10 comparisons. But if we compare with linear search, and if we are searching 10 in this, you see the linear search will compare with 1, then 2, then with 3, then 4, then with 5, then 9, then with 10. Then it will compare with all elements. Okay, that may at least 10 comparisons will be required. At most 10 comparisons will be required. While in binary search only 4 comparisons are required. You see that how much time is reduced. For example, if one comparison requires 1 second, then you can say that the linear search will take approximately 10 seconds and the binary search will take approximately 4 seconds, almost a decrement of 6 seconds if we are comparing only small elements. This algorithm actually appears to perform better as the problem size gets larger. Our list of 9 entries require at most 4 comparisons, whereas a list of 10 lakh items, if there are 10 lakh items, requires at most only 20 comparisons. If we are searching the element in the list which are having 20 elements, then also this algorithm will require only 20 comparisons. You see, while linear search will require 10 lakh comparisons. How much time difference come when the elements are larger, when we are comparing the binary search and linear search. Okay, now we are doing the program. Okay, for example, here the output is not printed. Sorry, we have not printed the output. In the binary search, you see that we have given a list of 9 elements, let's say from 1 to 9, and these elements you see are arranged in the ascending order. Then we are applying on the binary list. We have to find a target element which is given and the list we are passing. Okay, initially we have set the variable left as 0 and we have set the right, that is we are setting this index number to the left and this index number to the right. Okay, this index number 9 to the right. Okay, length of list minus 1, that is 9 minus 1, that is 8. This index number will be basically 8. Okay, this index number will be basically 8, and okay, this index number will be 8. and we see that right is equal to length of list minus 1. Okay, now if we check, if left is less than or equal to right, but if 0 is less than or equal to 8, then we are calculating the middle position by using the floor division. When we find the middle position, then we compare the target value with the middle position. If the target value matches with the middle position, then we return the middle position, that midpoint is returned. Otherwise, we check if target is less than the middle position, then target is less than, then the rightmost index number will be decreased by midpoint minus 1. Otherwise, we will increase the left portion, left index number by midpoint plus 1. Okay, and again the loop continues. Again the loop continues till the end, when the element till the element is not been found. Okay, when the element gets found, then we stops, and the output will be printed. Okay, here in this you see we are searching for the element 3, and you see that the 3 is present at the index number 0, 1 and 2. Okay, so when we apply the bind search for 3 searching, then it will return the index number 2, which will be stored in the variable a, and it will print a, and the output here will be printed as 2. Okay, the output which will be printed here will be as 2 when we apply the program for binary search. I think you have got the concept clear of how the binary search is working. Just write this program and try it. You can create the list while working the program also, and you can get the result. Okay, coming to the next slide. Okay, now how the running time of the binary search can be calculated. Just see, the running time of binary search is order of log n. See, the running time of linear search was order of n. The running time of linear search was order of n, and its running time you see is log n. You see how much time is reduced, because log function grows more slowly than the linear function. There is just one loop with no nested or hidden loops. Okay, we have used here only one loop with no nested or hidden loops. Once again, the worst case occurs when the target is not in the list. Okay, worst case will be occur only when the target is not in the list, otherwise the element will be found. How many times does the loop run in the worst case? This is equal to the number of times the size of the list can be divided by 2. Up to the list will be divided by 2 until the quotient is come. Okay, quotient is 1. Okay, we divide the number of elements by 2 up to how many times? Till we get the result 1. Let's say we are performing this for k times, then n upon 2 raised to power k will be equal to 1, and the value of n will be equal to 2 raised to power k, taking log on both sides, and we will get the k. K is the number of times the loop will be working, and we will get log n. Hence we see that the worst case running time of binary search is order of log n. Okay, I think you have got the concept of linear search and binary search clear. I think you have understand the running time of how linear search is calculated and how the running time of binary search is calculated. These are basically the calculation of running time is the portion of data structures and design and analysis of algorithms. Data structures you have studied, and you have studied the complexity portion in that. Also, when you will study the subject DA, there also you will study the this concept in more detail. Okay, I think you have got the concept clear. You also understand from this algorithm that if the elements are sorted order, are given already in sorted order, then compared to linear search, we will basically apply the binary search for working. And if the elements are not in sorted order, then we will apply the linear search, or we can sort the elements and then apply the binary search, but the time will be increased. Okay, very much. Thank you for the attending the lecture of linear search and binary search. Thank you.